Alright, so we're going to go ahead and get started here, guys. As you know, we're working our way through this entire process, which is permission, followed getting permission, the most important step. Recon, information gathering, where we find what systems we're actually going after. Evaluation, where we find what's running on those systems. And now we're moving on to the funnest part, exploitation. We're actually going to dig in and attack these machines and find a way in. Next time we meet, we're going to go into escalation, and we may mix escalation and post-exploitation together. That way we can wrap up the entire process a little sooner and start diving into some stuff a little bit more in depth. Because at the moment we're doing an overview of everything, and once we have the framework of what we're doing, we'll be able to dive into a little bit more specifics, a little bit more unspecific software. So previously, last time we met, go ahead.
I have a question. On the findings we've got on the client so far?
We'll talk client after the presentation.
All right.
Yep. Okay, so previously we went over vulnerability scanning. We were using Nmap and Nessus to find out what vulnerabilities were available on our target machine. Since then, I've played around with a little bit with OpenVAS, which is the open source fork of Nessus, which is also very nice. But I've also used Nexpose, which is created by Rapid7, the same people behind a lot of the tools that we use. It's been absolutely fantastic. It's probably my favorite one that I've used so far. So if you guys are exploring vulnerability scanners in the future, feel free to put Nexpose from Rapid7 at the top of your list. Yeah. So our vulnerability assessment tools were Nmap, Nessus, OpenVAS, and Nexpose. And this is by the Rapid7 guys. I'm actually pretty impressed with that. They had a representative even call and follow up, asked if we had any problems, asked if there's anything we needed, any suggestions, that sort of thing. Very nice interface, very nice output. So if you guys are looking to play more with vulnerability assessment, which I think is one of the most critical things that we do, that's an excellent one to look at. So today we're actually going to get into exploitation. And exploitation is huge. There are so many different forms of it. But just to do a quick overview, there's social engineering. And social engineering is when you use psychological manipulation of people to get them to perform actions or divulge confidential information. What's the easiest way to get somebody's password?
Ask them.
Ask them. That's social engineering at the very lowest, simplest level. If you have a clipboard and you look official, people love to give you their password. There are other methods of social engineering, such as phishing, and others. We're not going to get into that right now, but we know it's out there. Another form of exploitation is password cracking. Now, there's a couple different. The way people should be doing passwords is you get a password in, and you push it through what is supposed to be a one-way hash. And then you store that hash. That way you're never storing anybody's password in plain text. If you do that, like, what was it, Sony's PlayStation Network, then you have big problems, like Sony's PlayStation Network. So in theory, these are one-way hashes. But there are usually ways around that. If you're trying to do password cracking, especially like on a router or another device, what would be the very first thing you try?
Admin.
Yep, default username and password.
Admin password.
Yep, you go for the default. If you were just breaking it by hand. Default username, password, user/pass. If default doesn't work, you can try common ones. And if common passwords don't work, there are some tools built into Kali that allow you to try to crack passwords. There are two different categories. There's online and there's offline. We're going to talk online first. online tools remain connected to the internet and start sending information over in an attempt to crack it while it's live. There are two programs that do that are called Hydra and Medusa. I just watched Captain America last night, so it's hard not to say Hail Hydra every time I see that. The way these work is they use password lists, but what good is a password list without a username? Remember, in the vulnerability scanning point, in the evaluation stage, and in the recon stage, we're looking for possible usernames. Use these usernames in conjunction with the password list that you get out there. Now, when it comes to password lists, is bigger better for an online cracker? Do you want to be thorough or do you want to be concise? Anybody got a guess? 50-50 chance? Concise, yes, because you are online. It's going to take a certain amount of time to process this each time. But we're not necessarily talking like websites. We're talking SSH, FTP, anything that's got some kind of remote logging. So yeah, bigger is not better when it comes to password lists because a lot of people implement some form of throttling. That way, you can't submit 1,000 requests a second because, hey, that looks a little bit fishy there. But it's hard to generate your own password lists. But inside of Kali, you are given a few dictionaries to start with. If you look under your user share word list folder, you're going to have a handful of word lists inside of there, including, is it Rock4U or RockU? There was one of the biggest password breaches ever, and we have the output file for the most common passwords out there. John the Ripper also includes a password list inside of user share John/password list. That one's also very handy. So you can always look at the man pages to find out more information on these, but we're just letting you know that there are password crackers out there with the online variety. The offline variety has one major champion. There's lots of them out there, but the most preferred one, does anybody know it?
Kane.
Kane's one of them, but the one I want to talk about today is John the Ripper. So,
That's the name of the program?
yep, it's called John the Ripper. Now this one is offline. This is not a tool that you use unless you already have the hash. Because what John the Ripper does is it very systematically and very thoroughly generates every possible password out there. It then, when it generates the password, it will then hash that password and then compare the hashes. If a hash is written correctly, you should not be able to hash two words to have the same hash. It should just be one way, but we're following that one way with A, B, is on and on and on. So this can take hours. But this is one of the reasons it's crucial that you guys have longer passwords. Because if you've got four letters in your password and it's a PIN, there's only 9,999 possibilities, 1,000 possibilities basically. And how quickly can a computer run through 1,000? Yeah, faster than I can snap. So, if you already have the hashes, is John the Ripper your best option? Because it does take lots of time. Is there another tool you can use to find a hash? What do we use for everything these days? Most,
You can Google the hashes?
you can Google hashes, and Google's very good at organizing information, including the rainbow tables. We call rainbow tables the output of the reverse of a hash. So if you look up your hash, the rainbow table will take you back to the originator of that. They are usually available on Google. If you get bored sometime, go into your favorite language, do an MD5 hash, one of the easiest ones. You can almost guarantee your hash is going to be on Google, and it'll look it up. Sometimes you don't even need to crack a password. If you Google your common username, you'd be amazed at how often the password shows up in the first, second, or third page of Google results. It's amazing. What happens a lot of times is if you use the same username and password at many sites, if one of them is hacked, somebody's going to go through, run John the Ripper on the hashes, and then post the results online.
That's what happened with
That happens in multiple places. So, You can be online, you can be offline. What kind of access do you actually have to the computers in front of you? You have physical access to the computers in front of you, unless you guys are ghosts. Please tell me I'm not seeing a bunch of ghosts today. Using Kali as a live CD, there's actually a program on there that will allow you to reset passwords, dump the hashes, get everything you need out of it, called CHNTPW. So boot with the live disk, and you've got full reset and change and delete pass options available.
There was CHNTBW.
There it is. So physical, and that's going to be CHNTPW. Change network password. So we've got social engineering, we've got password cracking, we also have network sniffing. Now, you can make lots of giggles and jokes about that, but you guys have, how many of you guys have used Wireshark? Okay, Wireshark is a network sniffer. It allows you to see unencoded, what am I running up here? It allows you to view information that's passed through your, no, I'm trying to write Wireshark. Can you think about what I'm about to talk about next? Yeah, I'm going to talk about wireless here. So, my brain is glitching. Wireshark. Wireshark allows you to see the traffic that's passed over the network as long as you have access to it. This is very easy to do in a wireless network that's wide open. That's why I kept writing wireless up there. We talked, I think we mentioned Firesheep a little while back. It was a Firefox plugin that automatically sniffed the network on for usernames and session IDs. That was just a straight up Firefox plugin. And this is why you need to make sure things use HTTPS or you are using something other than an open wireless connection. I was going to talk about that in a minute, but oh, I did not include that in my notes. So, on a wired network, can you still do network sniffing if you have a switch?
If you're in promiscuous mode on your box.
Your card needs to be in promiscuous mode to be able to do any kind of sniffing. But when using a switch,
You have to
can you?
force it open, which is unreliable.
That's correct. But the way switches are different than hubs is hubs would receive information, send it out to everyone. Switches try to be a little bit better. They accept it and then only send it to the right person. Like as he said, if you flood that, and there's a tool that apparently I did not write down here, that will actually flood it with MAC addresses and overload it. Sometimes it fails open, sends it out to everybody, defaults to hub-like behaviors. Other times it defaults closed and the switch just shuts down. So you don't necessarily have to, it's not limited just to open wireless. You can crack encoded, if you're not using the right encryption on your wireless, or even with wired connections, you can cause some major problems there. And still get into it. Yet another form of exploit is man in the middle. And what that does is, when you're going from Alice over to Bob, you have another gentleman sneak his way in there and say, you know what, actually all traffic goes through me. I guess I'll be Charlie to follow their convention, and then I'll send it back. That allows him to read everything as it passes through. I was actually reading the other day, there's a way of doing this, spoofing and exploiting SSL as well. So be careful what you say. There's multiple ways to do this. This one, this was actually called MAC of, is the one that floods it and sends it back. I just put it in the wrong spot. There's multiple ways of doing man in the middle. One of them is art poisoning. Many, many more, but we don't need to know exactly, we just need to know the concept. We don't need to know the tools for it. And then the final one is typically, and these overlap, but can be things such as system vulnerabilities. includes things like buffer overflow, where you go if this is the area you have to write to, and somebody else has got stuff over here, you write beyond your buffer and write right through their stuff. If you do this well, you can get other commands to execute based on how it functions there. There is also SQL injection, where you get SQL to run extra SQL commands it wasn't meant to. Unvalidated input, where you don't scrub your data before you actually interact with it so people can cheat with it. Weak authentication and weak cryptography. So there's lots of different exploits out there. There's more categories beyond what I've gone over here, but this is massive. And there's multiple tools in every category. So this can get really overwhelming very, very quickly. But there is one tool to rule them all. The one that gets used everywhere. What is it, guys? Metasploit. Yep. Metasploit. Metasploit is actually a framework for the rapid development and testing of exploits, payloads, and other related items. What Metasploit does is, back in the bad old days, whenever an exploit came out, you would actually have to program it in by hand, including payloads and other things. So you would have to write an entire program from scratch to perform it. What Metasploit did is it broke everything up into a component. You have a exploit component that, I'm going to try to make these look like puzzle pieces, that plugs into, that has interchangeable payloads, which contain, shellcode, and we'll talk about that in a minute. So, this also has encoders, a lot of your tools. So, instead of having to go from A to Z, you've already got the rest of the alphabet built. You just want to try out a new C, swap in a new C. Makes it much, much easier, much, much faster to do. And it's actually become the de facto standard, so much that when an exploit comes out, there's typically a Metasploit component to go along with it. There's usually some code for it to show it there. So, Metasploit does a ton of things, and it can be very overwhelming. So, to simplify it down, we're only going to focus on exploits and payloads. And basic exploits and payloads to start. I want to give you guys a couple definitions. The exploit is a flaw. Where do I want to make that? All right, over here. So we have an exploit, which is a flaw or feature. Sometimes it's on purpose, just not used the way they intended. Within a system, an app, or a service. And the payload is a additional functionality that we add to the system. So additional functionality added. Now this payload typically takes this form of shellcode. And all shellcode is the instructions used as a payload. So if you kind of think of the payload carrying something, the payload is going to be carrying shellcode. And shellcode is what's actually being deployed, which gives you your functionality. So there are a ton of different payloads out there, but but there's a handful of common payloads, functionality that we want. What's the best thing to have on a system? Okay, interpreter, but let's step back from that.
Like root.
Yeah, root, but what are you running root from? You find them on the beach. Yes, shells. The best thing is to have a shell. Now, have you guys ever heard of a reverse shell? Okay. This can be slightly confusing, but it's not, it doesn't have to be. A shell is you, so if this is Callie, and this is your victim, a shell goes in this direction. The connection is made this way, but a lot of times firewalls and such block access on the ingress. So what a reverse shell does is it initiates the connection from the victim, not from the attacker.
Come over here.
Exactly. We have candy. Get in the van. That's where we're at there. You can also add a user. You can exec, and this allows you to execute a function on that machine. What's the problem with the shell? There's a connection there. You can see it. Some things it can be semi-permanent. So when you're doing shells or other things, sometimes it's easier just to execute a quick command. That way you're not sticking around. And as Josh said, interpreter is awesome, and we'll talk about that next time.
Are the shells like the TTY1?
Not exactly.
Command.
The shell is just any connection, any command line you can get into it.
Okay.
The other ones have some. GP was actually talking about the origin and some of those where the TTY1 is from the teletype virtualization from 50s or 60s or forever far back, but similar. As long as you have a shell, any kind of command prompt you get. An interpreter is a shell on steroids. Includes a lot of extra functionality to help you exploit. We'll talk about that next time when we get into escalation and covering your tracks. So, Metasploit does a lot, but it's, there's one other word I need to find. So, if the attack going to the victim is pretty easy to do, but if you're having the victim call you back, if you call somebody and say, call me back, what do you got to do? You got to answer the phone. So you'll hear about listeners. A listener is just it waits for incoming connections. So if you give your phone number out, you better answer your phone when somebody calls you.
Unless you're creepy.
What's that?
Unless you're creepy and just hear the breathing on the other end.
Yeah. Well, you have to answer the phone for the heavy breathing. So, not that you really want to. That's why we invented caller ID and other things. There's always the escalation. So the very first time you run Metasploit on your home machine, there's a few steps you should probably do. It's over here. Oh, any questions so far? We've got a lot of categories, a lot of things in each category, but we can primarily use Metasploit for a lot of it. So inside of Metasploit, the very first time you run it, there's a few steps that you can probably run through at home. It uses a Postgres database on the back end. So, and this is all lowercase. I just don't know how to write lowercase. Sorry. You need to start up your Postgres SQL server. And then you need to start up your service, your Metasploit service. Now, when you start up you start up your Postgres server first, because Metasploit is going to create a database for it to run. To actually get into Metasploit, you run the MSF console. The first time you run this, it may take a very long time to start up. If you've done the previous 2 steps, it's going to create all the tables you need. And it's also going to check in to make sure it's got updated definitions. Although once it finishes loading, it's a good idea to run MSF update. And that's going to give you new definitions. It's a good idea to run this once a week or so to make sure that you're completely up to date. To make sure your database is connected, you can type in DB status. And if it's not connected, log back out and restart. If you want to find out how many exploits, it'll show you how many exploits, and you can list them with show exploits. And you can also show payloads to find out everything that you can do with it. Now the Metasploit console is actually very, very cool. It actually works a lot like a normal shell, but with more functionality. So you can run Nmap from inside of here. You can run a lot of your other programs inside of here. You don't have to jump in and out of the console to run everything. So the exploits inside of, how many of you guys actually got to run some vulnerability assessment? Did you guys look over those pages at all? Okay, a few of you guys did. Did you notice that there was a whole bunch of CVEs in there? My back is turned, so nodding your head's not going to work. Okay, I heard a yes. CVE is a common vulnerability and exposures. CVE, common vulnerabilities and exposures. This is kind of the official ID of most bugs. After you run your vulnerability assessment, if you look through, you can typically find some CVEs of some very critical bugs. Inside of Metasploit, you can use the search functionality to find it. So you can just type in search, and then whatever CVE you have. If there's one available, that means you can take advantage of that exploit. So, if you do a show exploits or show payloads, you're going to have screens and screens of output. And again, it can be kind of overwhelming. So there's actually a very, very simple, very common pattern that you're going to use almost every time. As soon as I finish racing the board. So one of my dreams of a smart board is where you have instant, click the button and everything clears. Either that or them hiring like a Vanna White type person to follow along behind me, board prepped. So you've got a very standard process. Typically, you're going to search for an exploit. After you search for an exploit and determine which one you're going to do, you're going to use that exploit. Now the names are long with lots of slashes because they're categorized into if they're Windows, Linux, subfunctions, all the way down. So tab complete works inside of here and it is your friend. Once you are using an exploit, your prompt will change to show that you are using it. And at that point you want to show payloads. This is context sensitive. So if you are able to get a shell or a reverse shell with it, it will list that. If you can't get a shell, it's not going to list it. It helps narrow down from your hundreds of payloads down to the ones that actually apply. From here, you're going to want to show targets. A lot of exploits can auto-detect which OS it's attacking and customize itself for that, but it's still a good idea to show the targets and make sure you're using the right target. After you set your target, you want to show other options. So you type show options. Again, context sensitive. So if you have a reverse shell, it will let you know what machine to connect back to. These are going to be things like target, which we talked about, rhost, which which stands for remote host, that's the guy you're attacking. L host, that's you. And possibly any ports that it needs. Again, this will vary over time, but these ones are very common. Once you know what you want, you can set your option equal to whatever value you need there. And from that point, you just type exploit, and magic occurs. So this is the process every time. It may seem overwhelming with all the things you can do, but search, use, oh, I forgot to use a payload. So instead of show target, because we've already got that as an option here, we're going to set payload. My apologies there. We're going to show our options, we're going to set the necessary ones, and then we're going to exploit. If you are using lhost a lot, are you going to get tired of typing that in every time? Good programmer is a lazy programmer. There is a, I can do it right here. Instead of set, you can do a set G. And that sets it globally. Equals value. And if you want that to stick around for every time, after you're done, just type in save. If you want more information on something you're using, try the info command. And it'll tell you what you're working with there. So it can be overwhelming, but when it boils down, there's a very simple process you use with it, and it's kind of cool. When Metasploit originally came out, their lines was hacking like the movies. But in the movies, you don't really see the command line much. What do you see?
Some terrible visual basic GUI.
Yes, you see very terrible GUIs. But we're actually one step up on it. There is, Metasploit actually comes with multiple types of interfaces. And one of the most popular is one called Armitage. This is a nice, clean GUI that makes the entire process a little bit easier to get your head around. It's got some awesome features. If you're on a red team attacking, it actually allows you, instead of everybody establishing their, if this is you and this is the vulnerable, the victim machine, and this is your friend and this is your other friend, instead of having everybody have connections in, there can be one Armitage server right here where these guys all connect in and he connects in there. It's a lot easier for one connection to sneak through undetected than it is multiple. So it allows session sharing, it allows a lot of other features, but one of the coolest buttons on there, it's not exactly framed like this, but this button exists. Yes. It's not the exact phrasing of it, but this functionality exists. It will throw absolutely everything it has at every victim it can find. It doesn't take a whole lot of skill. It's noisy as hell. It is not subtle. This is, go ahead.
It's like the actual gun machine.
Yeah, this is a flat out, this isn't even a machine gun. This is the Incredible Hulk bashing his way through New York City in bunny slippers with machine guns hanging off his arms, with maybe a siren on his head. There's got to be something loud and obnoxious in there. But Armitage gives a lot of other functionality and a graphical interface for Metasploit, but this is the functionality that typically uses. It's better to learn Metasploit first so that you know what you're doing, and then move into Armitage. But if you have a rough day and things aren't quite going right, go in there and just kick some ass, and you'll feel a whole lot better about the entire process.
So can you talk about the magic part?
We will actually demonstrate that during lab today.
Okay.
So we're going to run through the, we've got about 20 minutes left, so I'm going to go ahead and end the presentation here, and then we're going to actually use the Metasploit and use a little bit of Armitage on our local machines. Any questions before we wrap it up? All right, let's go ahead and take it there.